Good afternoon, everyone. Thank you for attending session 9 of the IBR webinar series. As a reminder to all participants, this webinar is public and is being recorded. The registration information was posted on the NERC website and widely distributed. Speakers on the call should keep in mind that the listening audience may include members of the press and representatives of various governmental authorities, in addition to the expected participation by industry stakeholders. Should you wish to ask a question during today's webinar, please use the Q&A feature. It is NERC's policy and practice to obey the antitrust laws and to avoid all conduct that unreasonably restrains competition. This policy requires the avoidance of any conduct that violates or that might appear to violate the antitrust laws. Any NERC participant that is uncertain about the legal ramifications of a particular course of conduct or who has doubts or concerns about whether or not NERC's antitrust compliance is implicated in any situation should contact NERC's General Counsel immediately. At this time, we'll hear a few words from Alex Shatter.
Thanks, Lavitra. Thanks for kicking us off, and welcome everyone to our final week of the NERC IBR webinar series. This is going to be a kind of a packed week. We've got 3 in a row, today, tomorrow, and Thursday. And what we're going to kick off today is commissioning. So we've heard a lot of stuff from kind of all other aspects of the interconnection process and modeling and things like that. And now we're kind of coming to the intersection point between study work and putting those things into service. So we'll get a lot of good perspective today from a utility, or from an ISO, from a developer, and also from an OEM. So we have a full cross section of those folks, or most of the folks involved in the commissioning process. So thanks for joining us. We have, again, 2 more this week. After the webinar series this week, we'll be posting all of the recordings, as well as the meeting minutes, meeting materials, and kind of an FAQ from what's in the Q&A that don't get answered by us today. So I think with all that being said, let's just jump right into it, and we have Alan from ISO New England who's going to kick us off.
Alex, just want to do a quick sound check.
Yep, sound good.
Okay, great. Well, thanks for the introduction, Alex, and thanks for all the setup work, Lavitra. And thank you to NERC for this webinar series. This has been a really good series so far and packed with lots of really good information. So thank you very much for doing the work to put this together. So again, my name is Al McBride, Director of Transmission Services and Resource Qualification at ISO New England. And I'm going to talk about new resource commissioning in our region. So let's go to the next slide. So just the highlights, I'm going to talk about our technical requirements for the commissioning of new resources in New England, and including, obviously, and relevant here to the series, inverter-based resource interconnections. And just a note that this is a dynamic space. We are expecting to expand these requirements as part of our adoption of IEEE 2800, and I'll talk about that some more when we get to the end of the presentation. So next slide. I think we have 3 quick slides just to introduce ISO New England to those who are not familiar with us or not very familiar. So we have 3 primary roles in the New England region. We operate the power grid in real time. That's the wholesale grid and high voltage transmission system. We design and administer markets for the electricity commodity. And we also obviously plan the power system, studying for the future grid over the next 10 years and beyond. The next slide. So we are the regional transmission operator for the 6 New England states. Some statistics here on our transmission system and our connections. We do connect, we have two Canadian regions, the Maritimes and New Brunswick, and also we have HVDC connection to Hydro-Quebec. And we obviously we have connections to New York, to our west. We are relatively at the end of the power system, at the end of the Eastern interconnection, and that has manifested as some weak grid performance. You can see it as parts of the grid in New England that are relatively sparse and susceptible to weak grid performance. Also where some of our inverter-based resources have been trying to connect. Let's go to the next slide. And this is just the queue. I think all regions are seeing penetrations of this nature. Our interconnection queue at the time of this reading had over 35,000 megawatts of new requests in the queue seeking to interconnect. You can see that almost half of those are wind. It's mostly offshore to the southeast of our southeast coast. Also a lot of battery storage and solar. All of those being inverter-based resources. Just for perspective, our current net peak load in the summertime is about 26,000 megawatts, so well over our net peak load of new generation nameplate seeking to interconnect. Let's go to the next slide. So, and then on to the next one, we're going to talk about new resource commissioning. Now, probably like most market-based areas, the new resource asset registration process has numerous steps. We have to get generators ready to participate in our markets, bid into our market systems, be modeled in our energy management system, connect in our SCADA. And so all of that takes place, and as part of that process, we have specific technical requirements here of interest to inverter-based resources. And I'm going to talk about model and data submittals and demonstrations of power factor, voltage response, and frequency response. So next slide. So the model submittal sequence, and you would have seen it when we presented in an earlier webinar. There obviously is a lot of model requirements now associated with inverter-based resources. And the relevant sequence here is for an interconnection request, there is obviously the version of the model that will be used for the study. Then as we're approaching synchronization, there is the as purchased data submittal, which is, while not yet fully in service, it's expected that the generator can provide a set of modeling information for what was purchased and is being installed. And then the as-built data, which is part of the commissioning process. This is required prior to commercial operation, is expected to be similar to the previous submittals and consistent with that. And we do have model acceptance testing that we push this through, which is aligned with NERC standard mod 2627 voltage response and frequency response modeling standards. Let's go to the next slide. So our model acceptance tool, we use this throughout our model acceptance efforts throughout the sequence that I just provided, but it's especially relevant in commissioning. And like I said, for mod 26 and mod 27 demonstrations, we can run the model through this automatic application, which will check its parameters and its performance against various requirements to ensure that it's working well. And this has been very helpful to us in automating this work and allowing for the quick check of updates to models as they're needed. Let's go to the next slide. And so just to show, this gives an indication of the number of tests that are performed and the extent of what the test is relevant to and what it's testing for. So we do this, like I said, when we are accepting models from as-built generators seeking to go commercial, that the model's in proper format, test report documentation was provided, that it initializes, and that it goes through a stable performance when there's no disturbance. We look at the exciter response, the governor response, and we run some tests, single line to ground, line to ground, line to line, and three-phase faults. And to be accepted before a generator can go commercial, the model and data information must at least pass these tests. Let's go to the next slide. Included in this, everything I was describing was mostly focused on the PSSE, steady state and dynamics files. But similarly, we are vetting for accuracy, usability, and efficiency, PSCAD models for all inverter-based resources. We're benchmarking them against the PSSC models and against the as-studied information using things like single machine infinite bus analysis and playback testing. Let's go to the next slide, and I think we're going to move over to the performance testing of the actual capabilities of the machine that is being installed. So we do have a power factor demonstration where it's required that the device absorb and produce the maximum reactive power capability until a defined limit is reached, and we're looking for that limit and limitation, and what is causing it and what the extent of the limitation is. We're looking for maximum excitation limiters, under excitation limiters, volt source limited, terminal voltage limitations, or procedural limitations, as they are manifested in the equipment. And where there are multiple devices, say connected on a feeder, or where there's a power controller controlling multiple devices, we will run this test running all of those devices that may interact with each other at the same time to make sure there isn't any common limitation or anything like that. And the result of this test will be a megavar capability lagging and leading that will be associated with the resource going forward. So next slide. Voltage regulator testing. So this is looking at the dynamic response of the voltage regulator to ensure that it's enabled and to ensure that it's responding as expected. We obviously require the AVR or its equivalent in the case of an inverter-based resource to be on an inverter control mode, voltage control mode, and we look for 5% changes in the reference point, and look for corresponding response from the generator in response to those changes. And we request validated test recordings to be sent to us. And on the next slide, I have an example where there is changes in the reference point up and down. And then we're seeing, as the reference point is changed, the voltage, it might be difficult to read all of the pieces, but that the more curvy blue line is the voltage feedback signal, and the resulting voltages of the facility are changing in response to the changing reference point. Let's go to the next slide. Similarly, we require frequency response testing, and we have performance requirements of summarized here. A droop between 4 and 5% based on the nameplate of the facility, a dead band of no greater than 59.964 to 60.036 hertz, and that the real power response is not inhibited by the effect of any other loop controls that would override the governor response. We have various condition requirements, measure the megawatt output, and there be variant sizes of step change, no less than 50 millihertz, and that this test is performed under different loading conditions, say full load, partial load, things like that. And in the next two slides, if we go between them, this is a case where in the commissioning testing that I just described, we were able to see a sluggish response that we were able to work out of the generator by going back to them. In this case, they had enabled some additional capability that was slowing down the response of the frequency responder in response to the change in the reference. And then we worked with them, identified what had been enabled in there. And on the next slide, we got them to disable the extra step that they had put into the response. And there you see a much quicker and accurate response, not delayed, not sluggish. And this is what is actually enabled now in the field. So next slide, I think, is a wrap-up slide. So we're going to continue, obviously, to do the commissioning, adoption, and testing requirements that I described, but advance them by adopting more formally the full set of requirements of IEEE 2800, where we're specifying actual performance expectations, say in terms of things like response rates, and looking at that they be specifically demonstrated when the resource comes online, either in conjunction with IEEE, the testing P28.2, 2800.2, or in the interim with developer provided validation while we're waiting for all of that, all of those standards to be put in place. And I think that takes me to the end, Alex.
Thank you. Very good presentation. Good to see that perspective on the commissioning process. So thanks again. We'll take all the questions at the end during our panel session. Next, we have Katie Iverson from AES, who's going to give us the developer side of this process. And just a small pitch before Katie gets on is Katie's she's leading with one of the NERC IRPS work items on the commissioning process. So if anyone likes these presentations today or wants to get involved in that specific work item or any of the other work items from IRPS, just let me know, send me an email or Katie an email, and we'll get you added to that group and you can participate in that NERC work item. So that's it for me. Katie, it's all yours.
All right, thank you, Alex. So I will be covering traversing the commissioning process from the developer and owner perspective. So AES Clean Energy, we develop and we also own and live with these projects throughout their life cycle. I am the generator modeling manager at Clean Energy, and I'll talk a little bit about why this has even come to me. So next slide. So why do settings matter and how do I get here? How did I get here? So settings are on individual inverters and turbines. Going forward, I'm just going to say inverters, sorry wind people, but they have the same kinds of things. And they govern really important aspects of your plant behavior, your ride through. They even govern how many megawatts, MVA, MVAR, that's going to come out of each one of these little devices. There's a whole range of settings, but they do matter because they are, do you stay connected to the grid? Do you cease? Very important things. And they are key elements of power flow models. I'm not a commissioning in the field person. I'm here because I oversee power flow models, and I really started asking a lot of questions about this when I started doing this and really discovered there's such key impacts between how something is commissioned in these settings and what your power flow is doing. We spend a lot of money, a lot of engineering resources, and a lot of time studying these models, and they're only as good as what you put out in the field. So that's kind of how I have been involved in this. Next slide. A little bit of background so that we're all on the same page as I go through this. That some of the types of settings, like I said, ride through, grid support, normal operation, communication and restarts. What happens if you lose comms? Does your inverter drop off? Does your inverter keep going? That's all in these settings. Monitoring and logging, and there's also some aspects of security. Overall, they're loaded in finality at hot commissioning, but they can be loaded, some settings, in the factory and things like that. I'm not a manufacturer, so hopefully there's some manufacturers that can give a little more background on this, but this is kind of the crash course here. There's finality at hot commissioning, so this is like a bit before your COD. Next slide. So what have I learned? I wanted you to come away with 3 things that I think really relates to this process, and really that's it. I think it actually applies to a lot of things we do in engineering and life, but the first is collaboration and communication is key. The second is be curious, and the third is document and verify, and I'll go through each one of these. I've done this with many different manufacturers. I've seen a lot of different things. I know other developers and owners have too that I've talked to. So these are the 3 things to take away here. So next slide. A single leaf working alone provides no shade. And that is definitely the case here. As an owner, as a developer on your own, you can't go out and get these settings commissioned right. You're not going out there. As a manufacturer, you go out there and put settings on. If you don't have information from the owner or from the utility that has come through the owner, you also are not going to be very successful in building and commissioning a plant that does what it's supposed to do. So the commissioning team really must have the correct settings to commission. Now, this can be challenging because, as we know, communicating across departments can be hard. A lot of times this information is within different departments. Your commissioning department on the ground is a different department than the engineering department, than the sales department who's been in communication with the developer owner. And there are also different departments within the owner team that has looked at some of these settings. So really developing this setting sheet and settings information is very cross-collaborative across the OEM, the owner, the utilities, and across multiple departments there. So really communication and collaboration is key, making sure all of the stakeholders have reviewed, all of the stakeholders have received the information, and that the commissioning team, they're not just putting on default settings, but they've actually received the settings that need to go into that plant. And these are the same settings that are within your models that are run, and we've had previous webinars on that, but that are really run by the utility to know what's going to be going out there. So they're very important. Next slide. So the other thing about this that I've realized is you really have to be curious. Don't make assumptions that communication has happened. Don't make assumptions that all of the deliverables you're getting are consistent. Don't make assumptions that your model is exactly tuned to what's being put out there. Ask the question. I have no special talent. I am only passionately curious, which is part of why I even know about some of this, is that, you know, I like to ask those questions. And whenever I'm feeling kind of self-conscious about asking, like, have you received the commissioning sheet? Do you know what you're supposed to commission? When I'm speaking to people, I just remember being a child. We all need to embrace that more. It's not embarrassing. There aren't stupid questions. And you'll be really surprised by the results that you'll get, because sometimes the answer is no. Sometimes you think it's obvious, but it's not obvious. And sometimes it's far more complicated than you're really asking. So I always remember that's a picture of me when I was 8 years old, before I got that kind of, should I ask that question attitude. And I always remember that little girl, that you really have to ask questions and you really have to wonder what's going out there. As owners, we're responsible for these items. As utilities, you're responsible too. We need to make sure we ask the questions and be curious about it. Don't assume everybody knows what's going on. Seek understanding of the overlap effects of things. So let's say you have X settings and then you want to change a few things, or somebody wants you to change a few things. Think about and figure out all of the different things that if X changes, then another thing has to change. So like in your model, if something is studied and that's what's being used, then you need to commission based on what was studied. So if X is studied, commission based on X. But if it changes, Y needs to be studied and commissioned based on Y. You don't want to be mixing these things up. And I think asking a lot of questions, really understanding what is behind the scenes of these settings is really important to success in this process, because you can be kind of surprised by what you find out when you start asking a lot of questions. Next slide. So document and verify. This is really important because, like I said, we develop and then we also own. So there's a whole life cycle behind these that goes on after your plant is commissioned. So you really want to have quality on there. Verify your commission settings. Each one of these inverters has settings on it. And in some cases, these settings are put on in a manual manner. So there's manual input in the inverters, and that could be different. If somebody puts one into to one row or one into another row, that can change. But that's just an example of some of the QA, QC that needs to be done. And on the manufacturer side as well, like how do you set up your company to make sure that these are quality checks? Because like I said, they're very important. Your inverter can drop off. You can also limit yourself with your megawatts or MVA or MVAR. You can limit it so that you're not even able to output as much as you really could from that inverter. Power plant controller often limits it anyways, but we won't get into that. So really this verification is incredibly important from both the manufacturer side and the owner side. Trust but verify. I've done this a lot of times, and I hate having to recheck things, but I will say it's worth it here. And then retain your documentation. When you have an inverter that needs to be replaced, what do you do if you don't have those settings saved? How do you make sure that then if the manufacturer is doing repairs, putting another inverter there, that they are going to be putting the right things on? It's very hard if you haven't saved that documentation, and it takes field resources that you don't want to spend. If you just save the documents, save the notes, you have something to reference. So that's very important to this process. Next slide. So I've only touched the surface, so I don't have a lot of time. But where should we go from here? We have a lot of different inverters. We have a lot of different settings. So I gave a list of like 6 overall settings. Every manufacturer has a different name, a different code, a different definition. One could mean 0 in one manufacturer's setting. 0 could be 1 could be ride through, 1 could be don't ride through. And I think there's a lot that can be gained from learning from each other across our functions and organizations to understand what documentation we need, how we can best communicate this between the manufacturer, between the utility, and between the owners, because it's done very differently dependent on really all the different key players. And I think consistency in process and application is really going to help us there. And I don't see a huge amount of consistency yet. Making things easy is hard is the quote I have on this page. And I have a picture of a project that I did where I started shoveling, and I was like, I don't want to be shoveling. This is really manual and it's really not fun. And so I ended up deciding we have a lot of yard work to do. Let's buy a tractor. Let's make this easy. Let's get tools. Let's automate this as much as possible because I don't want to be out here digging. And I think that's part of what I want to see us doing as an industry with these settings. And also, like what you saw in the last presentation with the models and model checks, we really need consistent processes, clear documentation, and tools. There's no reason I need to manually be looking at a sheet against a setting sheet against another spreadsheet. These things we can grow a lot from here. So I think I want to make sure to highlight that we can learn from each other, we can have consistent processes, clear documentation, tools, and automation. And I think I want to address one thing that I get a lot with these individual settings as well. I get a lot of questions of like, well, if we did our Mod 26 testing, if we did our Mod 27 testing, if we submitted the model to the utility, is that good enough? And I want to remind or teach that testing is great, but it doesn't cover all of these items. It doesn't cover every setting. It doesn't cover the things that happen on a really fast time frame, like an inverter trip or a cessation. You don't see those things in Mod 26 and Mod 27 testing. So I wanted to make sure to mention that to this group is the testing is good. It gives us a lot of good information, but you also need to do documentation verification. There's just no way out of needing to do this. And it does help the grid. So So next slide. To recap, settings matter. It really matters how your inverter behaves. It matters if it trips. It matters if it matches what your model is. Lessons learned. Collaboration and communication is key, especially cross-functionally and across companies. Second, be curious. Always remember that little kid that's inside you when you're doing really anything, whether it be settings or anything else. It's good to channel that energy into our industry so that we can all learn from it. Third, document and verify. It's just essential. And then last, what is the future of this and where can we go from here? And then the last slide has my contact info in case you want to join the commissioning group.
Thanks, Katie. I was just going to do that pitch one more time. Yep. So this is Katie's email. Mine's on all the other information. If you want to join that commissioning work item and or IRPS, please feel free to reach out to us. That'd be great to have your contributions. I'm sure Katie would love some extra material helping to get that work item moving. So thanks, Katie. Thanks for joining us. We'll see you again in the panel session in a couple of minutes here. So lastly, we have another, where we have the first one today, but another one in the webinar series, manufacturer's perspective. We have Chris here from GE, who's going to talk about their perspective on commissioning. But Chris, it's all yours.
Sure. Hey, this is Chris Chua from GE. I work on the energy storage side in the solar and storage business, which is an inverter-based business. And, you know, giving my perspective, and Alex, you could go to the next slide. Probably a lot of what Katie said, you know, everything, and I'm, you know, relating the commissioning process and the overall OEM cycle down to what's relevant to this webinar. You know, starting with the grid studies, what we input usually is our UL 1741 data and any type test data that would be requested, and it varies depending on who is doing the model. You know, what comes out of that on the grid study would be the protection and coordination studies, short circuit studies, the load flow over voltage type of studies. And as Katie mentioned, you know, the important thing for us as inputs is the settings that come out of that. And, you know, the settings regarding relay protections, over voltage, under voltage, ride through settings. And then the grid loss, grid recovery time, pretty standard across the nation. And breaking commissioning down pretty simply, you know, there's the cold commissioning stage where we would do the configuration of the inverter, anything that wasn't done in the factory. And, you know, depending on what inverter we use, some of them come pre-configured for UL 1741, and it's as quick as, you know, setting the inverter to UL 1741, and it'll give us the standard settings for UL 1741. Sometimes there are special settings. You know, we have grid operators that have special settings that they would like to see as far as trip times and ride through times. And after all that's done, you know, we have the grid operator does the witness tests. And what are they mostly looking for? So they're looking to verify what we verified, the settings mostly, and then do some energize, and then do some testing on like grid recovery, grid loss, which is basically, you know, what you could do at that time and make sure the timers are right. And then once that, you know, the grid operator goes away, we'll get into hot commissioning where we import, export power and run through our performance tests, which will include contractually required with our customers, as well as any grid requirements for performance testing, which, for example, WEC. The WEC testing, you know, would be covered in this test section. Next slide, Alex.
Hey, Chris, if you're breaking up a little bit, if you mind turning
Oh, I
off your
am.
camera. If you turn
Yeah,
off your camera, maybe that'll help. Yeah, thank you.
yeah. Yeah, stop the video. Maybe it's connection. So what is our involvement? And that really depends on the scope and the contract. We have contracts as simple as equipment packages, which could be supply an inverter, supply inverter and energy storage containers, supply the plant controller as well. And our involvement would be really to commission the equipment, to provide and commission the equipment in that area. And it becomes a little muddy because we're in those instances we count on the customer to be doing all the grid modeling, have that interaction with them to get back all the proper setting information and to give them the correct input so they could do a grid model. Customers, sometimes they could be developers, they could be knowledgeable developers, they could just be, not so knowledgeable developers on grid code and necessarily what settings we need. So they become more difficult contracts to deal with when we get to commissioning, because there's a lot of questions on and a lot of unknowns as we get into the commissioning stage. And then, it progresses on to the EPC contract, which is the engineering, procurement, and construction. This is a turnkey type of contract where we, as the OEM, do everything, including so we have a lot of good collaboration inside, and we're able to basically eat our own cooking, if you will, on that kind of contract. But one of the difficulties in all these is that we have no direct contract with the grid operator. And at the end of the day, we have to go through our customers, and sometimes that's difficult because it turns into perhaps the customer is not knowing what the right questions are, and then we have to step into the middle of it, which creates a little bit of a difficult situation. Because again, we don't. It's not our contract, and certainly we wouldn't want somebody coming into the middle of our contract with our suppliers or other customers. So I went through at commissioning what happens, cold commissioning, where we'll verify the settings, prepare for energization, basically energize, which is the witness test, and then hot commissioning, where we'll verify equipment and system operation. I'm just trying to keep it simple here. And then really the next slide, Alex, which, what issues do we really see with all this? I made it pretty simple, but, the process is simple, but, the grid operator parameters versus the contract. Our contracts were obligated to our customers to provide certain things, but then we've come to find out that those parameters are often restricted by the grid operator. A good example is ramp rate. The technology that we deal with in IBRs and the contracts we sign are, aligned with millisecond response times on our technology. And then often when we get to commissioning, we're told to slow down. The grid operator wants minutes of, minute response times versus millisecond. The other area, the witness testing, finding that the scheduling and the scope varies wildly. We're finding scheduling these witness tests can push projects by months. There is no self-test and self-submittals on these witness tests. Some grid operators require the first energization at the witness test. What that means is, we've had no chance to test our equipment. Other grid operators will understand that and do the final witness test at a later stage. No energization means no commissioning, right? Commissioning is energization. So, I think a limited exception or some kind of self-witness across the grid operators would help, even if it's limited. So those are the two main, interconnection issues that we see. And I'm, trying to make this simple and not go into, examples of how many times we run into these issues, but it's a lot, and it can slow things down. And then Alex, the next slide, which is my last slide. Now, not necessarily issues, but some observations. I get to overview the commissioning of our systems globally. And I'm finding that the performance test specs and, IEEE P 2800 is probably going to change that somewhat. But right now, it's pretty much the WEC document and grid operators dictated, and a bit subjective on the criteria. They basically, the WEC document says match the model, and, it doesn't say how well. It doesn't give any criteria on settling time, response times, the typical CTQs, critical quality aspects that we've been looking at. And they're pretty quick. It generally consists of some step tests, some ramp rates, grid loss recovery. We write a report, we submit it, and we never hear about it again. In Europe, there's a document called G99, very prescriptive, voltage, frequency, active and reactive power. And it steps you through the cases that are modeled, the type test data that needs to be submitted beforehand, tests to be performed at commissioning. And then once those tests are done, we submit back, detailed reports and the results, with the CSV files and, whatever time intervals are required. And very often we get feedback on those tests. So it does seem to be more closed loop, as I find in Europe. And then the other thing, it's pretty curious again, as an observation, are the grid loss recovery times. And, I only see this mostly in the US, and I understand islanding is an issue, but, minutes to recover seems a bit long, especially after some type of grid event that counts as an outage. And I think that's about it. That's all I had to present.
Thanks, Chris.
Yep.
Good perspective from the OEM side. So of all of our presenters, want to throw your camera on or your mic back on, and we will get into the panelist questions. So it's the most fun part of the webinar. Let me just grab the participants so I can see everyone. All right. Let's see. Do we want to go hard first or easy first? Let's start easy. So I think we all or everyone kind of touched on it a little bit, that sometimes there are discrepancies between, studies and what's getting commissioned or vice versa. And then, what the real question is, when those scenarios happen, what happens? Like, how do you mitigate those differences? Is it like a full stop on commissioning until you get those reconciled? Is it like a restudy? And how do those things get handled, I guess, from each of y'all's perspective? And what does that kind of mean? Because I think everyone might be wondering, like, what does that mean? What does finding these issues mean for like the project timeline and things like that? So I guess your perspective on, how do you mitigate changes and how do you mitigate project timelines from everyone's side? And whoever wants it can just jump right in.
I can speak from the developer side. It really just depends on what the differences are. So in some cases, the mitigation has to be that they go back out and reprogram it into every inverter. Nobody's happy about that, so that's probably why we should try to automate this, make it easier so you can reprogram it just one time. And then other times, there's other things that you can do. Some things can be changed in the model without much impact, but it really has to be evaluated. And one thing I want to mention too is not every change is bad. So let's use ride-through for an example. If your ride-through is maybe better and it's still coordinated with your controller and it's still coordinated with your relays, then that's actually going to be a better performance. And a lot of utilities would prefer better performance. So it really just depends on what the difference is between what's really went wrong in the process and what's different.
Thanks, Katie.
Yeah, Alex, it's a good question, and it's a difficult one. I think you started off with one of the more difficult ones. Hopefully I'm interpreting that correctly. It can be a very pressurized situation if you have a developer who spent a lot of money is trying to get a project completed. There will be a lot of pressure to allow that resource to come online, declare commercial operations, and realize all of the the project milestones that get associated with things like that. But we do have occasions where we have to slow things down to make sure that things are correct. In some of the most extreme couple of examples that we've had, we really identified that in the two examples I'm thinking of, where the generator identified one nature of market participation which would not have required active voltage response, but came forward in a different way, in a way that did require active voltage response, active voltage capability. And we required that generator go back through the study process and eventually be enabled with full voltage control, voltage response. So that was painful for all of the parties involved, and what it did to the timeline and the experience. So I think lesson learned is maybe making sure the developer understands the decisions that they're making early in the study process, and trying not to be. I talked about the as studied, as purchased, as built. That's really important for us, and we want to make sure that going forward, what was studied is as close as possible to what is going to be what comes online.
Thanks, Alan. Chris, anything to add, or we can jump on to the next one if not? You may be on mute, Chris.
No, I think it was covered pretty well. Sorry, yeah, it was on mute.
Okay, yeah, no problem. All right, let's see. I have a couple follow-up questions. I don't know which one comes first to that one. So I think we all agree that the first thing to do is make sure that what's studied gets matched. You want to make sure what you're seeing in the study work is what's getting interconnected. And it sounds like Katie had mentioned, it's going to be kind of difference dependent. You have to review and find out root cause of the discrepancy and see what that effect really is before the rest of the process carries through. So really good answers to that question. Katie mentioned a little bit in her presentation, but I'm interested to see or to hear what everyone else thinks. But she mentioned that there is a disconnect sometimes between the study work, who all is doing the study work, and who all is doing the sales and commissioning work. And I'm just wondering if the other folks, if you all see it too, and what do you think kind of drives that? Is it just historical structure of the companies, or is it bad communication, or what do you think drives the disconnect between the different parties through the interconnection process? Maybe a really hard question, but
I would say one observation on that is we do see a lot of migration and requests to move to newer versions of the technology. This is a very dynamic space, and inverter-based manufacturers are always coming out with newer models, newer versions. So that's one driver of a new inverter model may have more bells and whistles, more things that are on there, and maybe with good reason, maybe for use in other markets and things like that. But if it's not what was studied, things like that. So migrations in the model or changes in manufacturer can cause that difference. The counterpoint for us, and it's right in our regulator, the Federal Energy Regulatory Commission. They require us to have a process to allow for developers to update their models and update their manufacturers. So it's something that has to be allowed to happen. But that's, I think, one source of differences in terms of what was studied versus what's coming online.
Yeah, good point. And just to be clear, Alan, is that the material modification process that you mentioned?
Yeah, okay. That's exactly the material modification. Yeah.
That was a really good answer. If there's no other thoughts, we can jump on to the next one, which is slightly easier or more fun. But any last thoughts on that?
I also
go
think
ahead,
that structure of the contracts, as I mentioned, some of our contracts, we're not doing any of the grid modeling, and it's really the customer's contractor that's doing it. So there is a communication aspect of it, and I sometimes feel like we're in the middle of that. We've done the full EPC contracts and know what we need for commissioning, but when we don't get it or there's no dialogue, and nothing to back up the settings files, there's obviously, to me, it's just a communication gap at that point, right? Or sometimes some of our customers not knowing that, hey, what the ramification is of having incomplete or incorrect information.
Thanks, Chris. That actually falls or leads directly into my next question, which is really good. I really flows right in nicely here. So I guess the next question is, and I'm going to use a term I made up completely on my own, but how do we mitigate, as an industry, how do we mitigate scope blindness, which is kind of what Chris just mentioned is, there's a lot of players involved. There's an OEM giving a default model. There's a consultant perhaps doing the third-party work for the developer. There's the developer, working in between those two folks, and maybe there's another OEM or two OEMs involved as well in the process. So, how does the industry increase the communication between all those parties and kind of stop what I just called scope blindness? Maybe like Chris had just mentioned, sometimes they don't do any of the work. They just give a model and then they don't hear anything again, maybe ever, right? How do we as an industry make sure that there's like the sufficient communication, and to make sure that from each of our individual scopes, how we make sure the big picture is appropriate? So any thoughts on that one?
I think each party has to understand what their scope is and be asking the questions. So manufacturer needs to ask, hey owner, you want me to commission this? Have you checked it with the model with the utility? Utility needs to ask, did you commission this with the model? Like, everybody needs to know the questions to ask of each other and making sure that that's happening. I think that's the first step. It's just the awareness to be able to have that curiosity to be able to ask. And then the next would be really, if we can streamline this more of like, these are the general settings. I think the IRPS effort that we've been doing is helpful in that aspect. So get involved. But yeah, that's just a little bit for me that I think everybody needs to understand and really mark out what their scope is and be aware of what the questions are. So like a checklist of like, I'm a manufacturer, these are the things I need to confirm. And I see that from some and I don't see that from others. And everybody kind of has to do their part here to be successful. And I think Chris said, like, we feel like sometimes we're caught in the middle. And I think in this case, with the models and with the commission stuff, everybody feels caught in the middle of something. So we all have to kind of band together.
Yeah, thanks, Katie.
Yeah, I think another aspect, at least, again, globally, my European projects, they're very prescriptive on what criteria is, at least on the, let's get beyond relay protection, right? That, has its own set of requirements and ride through settings and all that stuff. We can't test on site, but we have type tests that we could do that too. But again, it's very prescriptive of, hey, here's what the ride through criteria are. And then when you get to site testing, I have a very defined response time, settling time, things like that. And clear test plans. That at the end of the day, that's what we're all trying to validate. So that clears up a lot of confusion, and some of the standards globally are a lot clearer, more cohesive on that. Where if you're doing the modeling and the testing, it's all under one standard, and we're all after the same thing.
Thanks, Chris. Very good point.
Yeah, I think actually it was a really good question, Alex, and it kind of is the key question coming out of this panel. And this was, I think, a very interesting discussion. You had three entities here talk about the same thing in a very different way. The ISO was presenting things from the perspective of system performance and what we see from the system looking back into the unit, all the way down to the manufacturer talking more in terms of the contractual requirements and specific specifications. I think we know that we do need to evolve like ISO New England quite a bit, and start to think in terms of it's not going to be just verifying performance from a system perspective, but verifying, checking specifications, parameters, settings, and things like that. And I think that's what we have to do to bridge from our direction more into the other entities. I do agree with what Katie said as well. The other part of this that will make it easier for everybody is more standardization and more expected. What are the natural settings and functions and controls that we should be defaulting to. That will increase the understanding across the entities as well.
Thank you, Alan. And that's it for the questions. It sounds like you kind of summarized everything I was going to say pretty well. We got three really very different perspectives on the same topic from three different groups involved. And we have seen in the other presentations or other sessions that the variance of interconnection requirements across North America kind of leads a little bit to this confusion. A little bit more standardization could go a long way. If the developer, if Katie knows she has to do the same 10 things for every single project in the U.S., that makes her job a lot easier, right? And if Chris knows that all the inverters he sells in the U.S. need X, Y, and Z, he can do that much easier, and things like that. So I think the message here today is, communication is totally key. Understanding the big picture is also key. And we all got to work together to kind of standardize and work on the same team to get the reliability up and match everything to what gets studied. So really good perspectives and things today, really good presentations and answers to the questions, and I really appreciate it. So with that, we're going to do the little pitches at the end. We're going to plug things at the end of the session here. So if you want to join IRPS, just reach out to me and let me know. We're doing, Katie's commissioning work item. There's a couple other work items ramping back up. We have an interconnection process or interconnection studies work item, and a few other ones. If you want to join the discussion or join those work items specifically, give me an email or email Katie and we can get you added. There's also the EMT task force, which is similar to IRPS, but it's really focused on EMT modeling and model requirements and things like that. They're kind of working on the early scoping stages. And one of the things that's coming in the next guideline from the EMT task force is kind of a document that lays out roles and responsibilities for all the responsibilities and entities when matching EMT models to what gets installed. So it'll be sort of the similar thing, but focused on EMT side. So if you're an EMT person and you want to get involved, let us know. Same emails. You can email Ong or myself or Levitra. and we'll get you added to that. Or if you just want to be involved and learn about EMT stuff, you're welcome to come and listen and learn as well. So thanks everyone. We're gonna have 2 more webinars this week. Tomorrow is Wednesday. Just remember, we're breaking the Tuesday, Thursday mold for this last week. So we'll have one tomorrow, Wednesday at the same time, and then Thursday at the same time as well. Tomorrow we'll cover IBR registration activities, and then on Thursday we'll kind of wrap up the series and do a little bit of NERC's next steps and lessons learned and things like that. So thanks everyone. Thanks panelists. And we'll see you tomorrow.